Okay, so what we discussed this week was tissue engineering, which is a great advancement in medicine and science. There are many, many people every day that needs a transplant, and tissue engineering makes this possible. It takes stem cells, embryonic stem cells, which can be changed into any kind of tissue and other types of cells, as well as adult stem cells, which has to kind of stay more in the category of where they came from. Tissue engineering is most commonly used in skin and cartilage and bone transplants. Speaking of that, we do have 4 different major types of tissues. Our first one is the epithelial tissue, which is closely packed together with no blood supply. An example would be a simple squamous tissue, and it is found lining and kind of protecting your body. And its job is to protect, secrete, excrete, stuff like that. Our next one is our connective tissue, which is further apart. It has a matrix in between and then also has a good blood supply. An example of that would be actual blood cells. And it is the most widespread tissues and is found throughout your whole body. And its job is to support, to bind, to fill spaces, and also store fat. That takes us to our third type of muscle, or third type of tissue, which is our muscle tissue. Our muscle tissue can be identified by its ability to contract. It can be found in your heart, like cardiac muscle, which is an involuntary muscle, or skeletal muscle, which is a voluntary muscle. So obviously found in your heart. It can be found connecting to your skeletal bones and also lining organs. And its function is mostly to move. And then our fourth type of tissue is our nervous tissue, which you can identify that it connects to other cells and body parts. Its primary duties are sensory and integration and movement. And a specific type would be a neuron, which is, of course, composed of the 3 different bodies: the cell body, the axon, and the dendrites. And it can be found in your brain and spinal cord and, in your nerves as well. So if I were given a tissue sample, and trying to identify it, I would play a process of elimination and just use the knowledge that I learned this week. So obviously if it has the ability to contract, I'm going to, exit out and say that that's a muscle tissue. If it's connecting to other cells, then I'm going to say no, it's, resembling a nervous cell or nervous tissue, and X that out. And then if it's closely packed together, I'm going to assume it's epithelial tissue. And so it's not, in fact, connective tissue. And then finally, to confirm that's connective tissue, I would look for those main characteristics. Is it kind of further spaced apart? Does it have a matrix in between? That matrix is made up of the protein fibers and the ground substance. And then also, does it have a blood supply going to it? And if all those things are correct, then I am going to assume that yes, it is a connective tissue. So that is all the things we learned about tissues this week.